Once again, thank you everybody. We're about to get started. Today we have an informative webinar for you. It's very exciting about our microinverter line, and I'm pleased to be able to introduce to you Daniel Brenzel, our product manager for emergency lighting solutions.
Thank you, Jay, and thank you everyone for joining today. I'm Daniel. I'm the product manager for all emergency lighting systems at Fulham. And today we're actually going to walk through our exciting FireHorse Micro-Inverter family, what they do, where they fit in, and how they really can simplify emergency lighting design and installation. Let's get right into it. So at a high level, microinverters are essentially battery backup systems for lighting. They keep fixtures on when AC power is lost. So essentially AC power is lost, the fixture turns into emergency and essentially either powers it at full power or at a reduced power. And we can get into that more. And then they sit in standby when normal power is present. So the fixture operates normally and the fixture is just waiting to come on. Think of them kind of as a compact fixture level uninterrupted power supply. So similar to a power supply for your computer, that's sort of what an inverter will do. So if you have a power supply for your computer that comes on during a power outage to keep your computer on, that's sort of what this is as well. Now, the cool thing about inverters is that they are extremely flexible. So you'll see them across a slew of various applications: linear, high bay, panels, downlights, wall packs, basically most commercial fixture types. And what makes our microinverter so different is that we've built a lot of flexibility into our platform. The goal here with our inverters is to simplify your installs, but also expanding application coverage. So not being limited to what a traditional microinverter or inverter could power. Here are some of the key highlights of our inverter family. They're all universal voltage out, so they all provide a true sine wave, not DC, but an AC sine wave, 120, 220, or 277. And there's three power levels. So there's a 12-watt inverter, a 25-watt inverter, and a 50-watt inverter. And all of the inverters come with an integrated battery. So the three photos that you see there is no external battery that's needed to be connected to the inverter in order for it to provide battery backup. It's all integrated into one thing. One of the key factors of our inverter family is that we've essentially added 0 to 10 volt emergency dimming. So this allows the inverters to provide a dimming signal to the fixture while in emergency and dim that fixture down during emergency. So it allows our 12-watt, 25-watt, and 50-watt inverter to be used on a lot higher wattage load than just the stated wattage of the inverter. So our 12-watt can power a 100-watt fixture, our 25-watt can power 150, and our 50-watt can power a fixture up to 320 watts, provided that they have 0 to 10 volt. We can also, with our 12-watt inverter, power triac dimmable fixtures. And those fixtures can be up to 18 watts. That is something unique in the industry. I believe we're the only one that has that at this moment. Certainly, that's something that we're looking at exploring that wattage as well in the future. Keep in mind that fixtures that do not have dimming, these operate like standard inverters. So your rated load of the inverter, whether it's 12, 25, or 50, will be the load that you can connect to it. So you cannot exceed 50 watts if you're using the 50-watt inverter with no dimming. We'll cover some more advanced features of our inverters. So first of all, they're all CUL US listed. So that's UL listed for field installation, meaning that they can be installed in the field. And they all include self-diagnostic as standard. So the units will self-test once every 30 days and have a full self-diagnostic test once every year. Two of the units are programmable, so you can adjust the output of the inverter to support extended run times. So the 12-watt can be set to as low as 6 watts if you need an extended runtime, and the 50-watt can be extended all the way down to 10 watts if you need more runtime. All of these products have emergency battery disengage, or EBD. This allows you to disconnect the battery of the inverter without having to actually physically unplug the battery connector wire of the inverter. So you're able to do this through the test button. You hold the test button down when the unit is in an emergency mode, and it will internally disconnect the battery, and then it will reconnect the battery once normal power is applied to the unit. Now we're going to look at some wiring examples. So this is examples of wiring when dimming is not present. So we're using the 25-watt inverter here as an example. On the left-hand side, you have one 25-watt fixture connected to one inverter. And then on the right-hand side, I just wanted to show that it is possible to connect multiple luminaires to one inverter. So you have five 5-watt fixtures connected to one 25-watt inverter. Now here you have wiring when 0 to 10 volt is present. So your rated load of the 25 watt can now bump up all the way to 150 watts. So on this install, we have 6 25-watt fixtures. So that's 150 watts. And the 25 watts of power during emergency would be distributed evenly across all 6 luminaires. So each one would be around 4.1 watts. Obviously, if a 50-watt inverter was used on this install, that 50 watts of power would be distributed evenly as well, and you would get 8.3 watts. And now I just want to get into more detail as to how the dimming works and how the dimming function works. So during a loss of power, when 0 to 10 volt is connected to the inverter essentially turns on and immediately overrides the previous dimming level set by your wall switch. And so the inverter will override that and turn on the fixture at its lowest possible dim level. And then in a span of less than 2 seconds, the inverter will essentially ramp up the fixture's output until it reaches that rated output of the inverter. So 12, 25, or 50, depending on what model you're using. If the fixture cannot dim down to the stated wattage of the inverter, essentially our inverter will enter a protection mode, meaning that it senses that it will not be able to support the wattage that the fixture needs to turn on. It will essentially flash 3 times, and then it will turn the inverter off, and you will get a red derangement signal on the test switch indicating that you have overloaded the inverter. Now for the 12-watt microinverter, we're going to cover each inverter sort of in a little more detail here. The 12-watt model really is ideal for one-to-one solutions. So its max wattage load with dimming is 100 watts. And so really it's our ideal model for where you're installing one inverter to one fixture, which is primarily most applications out there. As I mentioned, it can support 100 watts with 0 to 10 volt dimming and 18 watts with triac. Self-diagnostic is standard, and it does have that EBD and programmability feature as well. Now for our 25-watt model, very similar to the 12-watt. However, people do use this at a fixture-to-fixture, one-to-one level, or even multiple fixtures, because it is compatible with up to 150 watts of load when 0 to 10 is connected. Next, our 50-watt model supports up to 320 watts. This is going to deliver a lot higher output than our other inverters and is used a lot on high bay fixtures as well as multiple luminaires. Again, same features as our other models. Self-diagnostic is standard, it's programmable, and it has the EBD. The programmability feature of the 50 watt specifically, I think gives you more flexibility. So in an install where you're wiring, let's call it multiple can lights that are dimmable, you can program the inverter to a lower wattage to essentially either give you longer run times or reduced output on multiple luminaires that essentially can heighten the application ranges of our 50-watt inverter. Now we're going to get into an installation comparison. This is something where the microinverters really shine when you compare them to their emergency driver counterparts. A microinverter essentially wires on the input side of a fixture. So the black and white, in this case, it shows LED driver, but essentially imagine that that's a fixture. The black and white coming off of the fixture wires directly to the inverter, as well as the dimming wires. Whereas on the right-hand side with the constant power emergency driver, you would essentially have to open up your fixture, gain access to the LED module and the output of the LED driver, and make those connections inside of the fixture or inside of a junction box on top of a fixture. So there's another couple steps involved there in wiring in a constant power emergency driver or any emergency driver.
We are now showing a side-by-side comparison of the wiring of each of these emergency systems. On the right-hand side is the 25-watt inverter, and on the left-hand side is your constant power emergency driver. As you can see, the constant power emergency driver has numerous wires. You will need to rewire the input, the LED driver output, the LED module input, and wire in the test button. The 25-watt inverter only requires the input to be rewired and the 0 to 10 volt in cases of more than 25 watts to be rewired. The test switch also has a quick connector to eliminate the need to wire it. Also, I would like to note that this is being done with a preset station. In a real-world application, the wiring of the constant power driver would be much longer as it would require you to open up your fixture prior to beginning the installation process. The inverter can just be connected to the input and dimming wires that are visible from the outside of any fixture. The inverter is finishing up now, while the constant power is still being rewired.
So as you can see, the inverter wires a lot faster than the constant power driver. There are benefits to our constant power line. There are a lot more various wattage options, as well as form factor and options that can be installed inside of a fixture. Also, they are more cost competitive up front. However, the inverter does make up for that cost in installation savings. Testing is another big challenge in emergency lighting. It's a large maintenance cost that many building maintenance people have to face on a monthly and yearly basis. And this is where our goal is to reduce that ongoing maintenance effort with wireless reporting options. So the first option that we have is the partner of ours, Hexmodal. They are a company that offers a wireless automated testing system that is completely hands-free for the customer. And so all communication is done through their system, and it does follow the current NFPA 101 self-testing guidelines. They essentially have a dongle or a reporting device that connects into the I2C port of our inverters, and that essentially allows the unit to be remote tested and allows you to do gateway-based scheduling and gather data from recent EM tests, current operational reports, or even failure reporting. So if there was a failure reported by a test, that would come through the Hexmodal system. This allows for very simplified testing. All the testing is actually monitored and done by Hexmodal. So a customer that is interested in this Hexmodal reporting system would essentially pay a monthly service to Hexmodal. So that subscription service includes everything that you need to essentially turn your building or your job site into a fully functional remote test solution. So that includes your gateway, all of your wireless dongles, and any also exit signs that are also compatible with the Hexmodal reporting system. On the right-hand side up at the top, you can see an example of how the data is gathered and then how it reports out. So at the bottom there essentially would be your EM test results and the paper that you would give to your inspector. when they ask for a monthly test report. So looking forward, we are also adding app-based commissioning through Silvair and through Keelton. Their apps, the Silvair solution will operate through our Fulham Elite Blue app. This app is already being used now for our Bluetooth bridge, but it will soon be updated to essentially support our emergency products. And the Keelton solution will work through their app ecosystem. So they would be through the Keelton app. Both of these, in order to essentially have the inverters communicate with both of these different solutions, a dongle is needed. And that dongle, similar to Hexmo, is installed into the I2C port of the inverter. And it allows for wireless configuration, remote monitoring, and remote commissioning. And it also can remote test units as well as provide reports every 30 days or once every year. Here's a little connection diagram. So you have your inverter and then your dongle connected to the inverter, and then that sends a signal to your app, and you're essentially able to view its status. If there's any errors, it will display there, or you can enter a manual test through the app to test your inverter as well. So to wrap up, the FireHorse Micro-Inverter family really delivers flexibility, simplified installations, and even now advanced controls. We really believe that this is a leading product in the market, and we really hope that you think so as well. Thank you for your time, and I'll now open it up for questions.